Good day, ladies and gents. And yeah, I'll be taking you through grade 9 geometry. But before we do that, I just want to give you a template of how we'll go about this thing, right? There are rules or fundamentals that you need to follow when you're dealing with geometry. And the first thing that comes in mind is for you to understand the following things, right? So let's just call them rules or whatever you might call them, standards. Standard. So number one, we have something that's called supplementary angles, right? So supplementary angles. So let's say this is A. So supplementary angles lie on a straight line, right? Let's say you have A and B. From this point to the other point, it's 180 degrees. So it's going to say A plus B is equals to 180 degrees. Then you need to write your reason. So every time when you use supplementary, you can always say supplementary angles or say angles in a straight line. So this thing is called angles or whatever, right? Then B, we have complementary angles. So if this is 90 degrees, then there are two angles in there, which is A and B. We can sort of like say A plus B is equals to 90 degrees. Then what's going to be your reason? Your reason is going to say complementary angles or angles are equals to 90 degrees, right? Then what else do we have? Let me think. Revolution. 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 Let's say we have a point and we have angles around that point. So we have A, B, C. So if we rotate from any point going back to the same point, then we call it angles around that point, right? So this angle is made up of, or this revolution is made up of A plus B plus C, which is equals to 360, because you're doing a 360. Your reason that you might use, you might say angles around a point, or say a revolution, or angles are equals to 360 degrees, right? That's the other rule that you need to follow. So far we have 3 and X. So the first guy is F. So if you have parallel lines, right, and angles in that point A and B. So if you have parallel lines and the angles in the interior of your F, whatever. So let's say A is equals to B. This is a rule, right? If you have parallel lines and it forms a shape of F, and within that F shape, here and here, right, those two angles are equal, then what would be your reason for that? Then you call this corresponding angles are equal. That's the first one. We have U. Let's say this is 1. Number 2, we have U. All right. So we have A and B. So this one is A plus B equals to 180. Your reason would be interior angles add to 180 degrees. These are rules, right? These are standards. These are rules. which we are going to follow. Let me add the last two, then we do triangles and we're done. We can start with our exercise. The last guy is N or Z. You can write it in any form, right? You can write it either way. So if you have parallel lines, then you know these two angles. So let's say A and B, A and B, A and B. So you know the alternating angles that we have here. A is equals to B. They are equal. So your reason will be alternating angles equal. That's number 3. Then lastly, we have X. So if we have A and B, C, B, these angles, A is equals to B, C is equals to D. And this is vertically opposite angles equal. Vertical opposite angles equal. What did I do there? Did I zoom out by mistake? Are equal. Right? Okay. I don't know if there's anything I need to introduce for now, but I think we can start with our exercise, right? I'll try not to use anything outside of the rules that I've introduced so that you can see that you can answer these questions using different methods and stuff. The statement says, given that QWR is parallel to Z SZAT, so they're saying this angle, this line QWR is parallel to SZAT. So we have parallel lines. Then in your mind, you have to already think of fun X, right? Because it uses parallel lines. Fun X. Already we have a straight line, right? We have straight line. We can use supplementary angles. So the reason why I'm doing this is to make you aware that you can be creative on these things. It doesn't necessarily mean that you have to follow a specific standard to solve a question. If supplementary angles work and you're applying it right, then use it. If fun X works and you're applying it right, then use it, because you can see parallel lines in there, right? So then they say WX, WY intersect at ST. So WX, WY intersect at ST. So it just intersect at that point. Then they also give you angles. They say angle W1 is equal to this guy, which is 65. And A2 is equals to 1, 3, whatnot, right? Let's proceed. Then they say to you, complete the statement in the table below to calculate the size of A1, W3, Z2, Z3. So let's start with A1. So A1 is this guy, right? So I told you, if something applies, then use it. Is this a straight line? It is, right? At this point, the whole angle is equals to 180 degrees. So it's going to say A1 and then A1 plus angle A2 equals to 180 degrees. What are we using? We are using supplementary angles. So using supplementary angles. Then already we have A2. It was given to us as 121. So you're going to say A1 plus 121 is equals to 180 degrees. Then transpose to the other side, or you can eliminate 121 by minusing 121 both sides, either or. So it's going to say A1 is equals to 180. When you transpose 121 to the other side, it will change its sign from positive to negative 21. If you want to do it the old way, this is going to be 7, this is going to be 10. 10 minus 1 is 9. We are left with 7 here because we stole 1. Then you say 7 minus 2. That's going to be 5. Then 1 minus 1 is 0. So angle A1 is equals to 59 degrees. Do you get it? Does it make sense? So if a rule applies, apply it. Don't force it, right? Because sometimes you might find people like forcing rules where they don't apply. But yeah. So we done with our first part. We know this guy now is 59 degrees. You can somehow go put him there so that you don't forget. It's equals to 59 degrees. So now going forward, we can use this guy to solve other questions, right? Then the next one, it says find angle W3. So you see this guy is here, right? So I just want to show you that if a rule applies, apply it. And you see we have N here, or so-called Z, right? Look at this. It doesn't matter if the Z is upside down, but I see parallel lines, right? I can sort of like draw my Z shape here. Look at me. So we know these two angles are equal because we call them alternating angles, right? So let me erase here. And let's solve our answer. So we're looking for angle W3, which is equals to A1. So you saw this guy we solved on the previous question where we got 59. So your reason is going to say alternating angles are equal. See, it's nice. Then you just go there and say, therefore, angle W3 is equals to 59. You're moving, guys. I trust you. So this is going to be 59 degrees. Do you get it? Does it make sense? Are you lost? Hope I'll find you soon before you disappear on me. But yeah. So we're done with these two guys. Then let's go to the other dude. The other dude, they are looking for Z2, right? So Z2 is here. Then I see something here. How can we find Z2? Okay, so since I didn't introduce new rules, I'll stick to the ones that we have, right? So I already see something at the top, which is in a shape of a U. Can you see? Right? Which is this guy. So we're going to say angle W1 is equals to angle Z2. Not equals to, what am I doing? So I'm going to say angle W1 plus angle Z2 is equals to 180 degrees. Your reason is going to say co-interior angles at 180 degrees. Then we solve. do we have W1? Yes, W1 is 65 plus Z2 equals to 180 degrees. Then we do our transposing and whatnot. So if we transpose 65 to the other side, it's going to change signs. So we have Z2 equals to 180 degrees minus 65. Do you want to do it the old way? Yeah, why not? We borrow 1, we are left with 7, and this is 10. 10 minus 5 is going to be 5. 7 minus 6 is 1. Left with 1, we drop it. So our angle is 115. So this guy is 115 degrees, right? Does it make sense? So since my thing is messy, I'll just erase the rest of the things that I've drawn here so that we can do the last question. Okay. So yeah, let's proceed. So I'll try and use a different method to answer the last question because they're looking for Z3, which is here, which I can sort of like just use straight line because I already have Z2, right? But let's think outside the box and see if there are any other ways to solve this. Okay, I see something already, right? F. Let me show you. You might be saying, this guy is crazy. Where's F here? Look at this guy. Right? This is F. Already you can see these are parallel lines. So we can apply F. So these corresponding angles are equal. Right? So you can see there are multiple ways to solve a question as long as you are within the rules that are made for you. So we're going to say W1 is equals to Z3. Reason chorus. Oh man. Cause my man, you're ringing in my mind. Corresponding angles equal. So it's going to be 65. Therefore, W1 is equals to 65. Z3 is like that. Or we can use a straight line as you said. So it's going to using only the 4 rules that are introduced for you guys, which is supplementary angles. Complementary, just that we didn't have 90 degrees in this case, so we didn't use it. Then we also have fun X, F for corresponding angles, U for complementary angles, Z or N for alternating angles, then X for vertical opposite angles are equal, right? Other things that you would have used are triangles, because already you can see a triangle in here. So I'm just trying to give you an idea of how to have that geometric eye, right? Because if you see a shape, then it's that shape. You're not hallucinating. So this is a triangle. Can you see? You can apply rules within triangles. So you see there's an extension here, right? There's an extension here. You can somehow use like exterior angles in a triangle. You see there's another extension here. You can somehow use exterior angles in a triangle. Like it depends on how you see it, right? But there are multiple ways to solve one question in geometry. It's not confined to one thing. Hence, you need to exercise so that you can have that instinct. Then you'll be like, when you're doing questions, like, this is how I can do it. This is another way to solve it. So it's a way of like exercising your muscles. You don't only use the index finger. You have to always use all the fingers like in a keyboard, sort of like, right? That's a stretch, like using an example like that, but for you to be geometrically inclined or have that instinct, you have to exercise the muscle. And this is how you do it, right? If you do one question each and every day, you don't even need to spend more than 80 minutes practicing maths, right? I sort of like do this with my little sister, right? I introduce a concept, then each and every day I give her one question to do. Then later on, she realizes that when she writes a test or whatever, she won't have the stress of going back to revisit the concept, revisit the rules that she needs to know for a test. Already it's part of her because she's been exercising the muscle on the daily. Just that she wasn't aware. She might see it as a punishment, but who cares? It's a future at the end of the day. So yeah. So spend 5 minutes each day. If there's something you don't understand, ask someone to assist you. Then continue doing that up until you know that you are confident enough to do these questions without even practicing, right? So yeah, that's it for me. Next time I'll introduce new rules and we'll redo this question and see if we can answer it in a different way. For now, this has been Isa and glad to share this. Cheers. Bye.